Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's topic. The topic is half-life. Students, in the process of nuclear radioactivity, a heavy unstable nucleus splits into two or more comparatively lighter nuclei with the release of nuclear radiations. Students, when an element will decay, when an radioactive atom will change into new atom, we cannot predict it. However, in this context, we use a term that we call half-life. Students, it is a time in which the number of radioactive nuclei in a given sample reduces to half of its value, and we denote it by T half. Students, half-life tells us that how long a radioactive element will take to reduce to half of its given value, or it is the time in which half of the radioactive atoms of a given sample decay. Students, to further clear the concept of half-life, let us consider a graph in which number of radioactive atoms present in an element are denoted along y-axis, vertical axis, and the time is taken along x-axis. If in the beginning we are having 100 radioactive atoms of an element, as the time passes, this number goes on decreasing, and when it becomes half, means it is reduced to 50. This time that it took to reduce from 100 to 50 is called its half-life. So after first half-life, the number has reduced to 50. Similarly, when another half-life, means a same period of time passes, this number further divides and reduces to further half. And after another half-life, it further divides to half. In this way, as the time passes, the number of radioactive atoms present in an element goes on decreasing. Generalizing this equation, we can proceed like this. If there are N0, general term, N0 is the number of radioactive atoms present in an element at time t is equals to 0. When one half-life passes, this number reduces to half of its value. Now it becomes N0 by 2. N0 has reduced to N0 by 2. Similarly, after another half-life, this number further divides to half, and we get, after second half-life, N0 by 2 is further divided by 2, and now N0 by 4 number of radioactive atoms are left. Similarly, after another half-life, this number further divides to half. Now N0 by 8 number of radioactive atoms are left and rest as decayed. By this way, we can generalize all these terms in a single term, that is, generalizing all these terms, n equals to 1 over 2 raised to the power n into n0, where small n represents the number of half-lives. So this is the equation that we use to find how much radioactive atoms are left after each half-life. Students, this is all about the half-life of a radioactive element. I hope it is clear. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.